In this video, we are going to solve Pearson Edexcel International GCSE 9-1, Friday 13 June 2025 for CH1 2C paper, okay? It is having some practical section also, and it is paper 2 basically, okay? It is having total 70 marks over there, and it is having total 70 marks over there. And you must have calculator for this paper, always remember, and use the black ink or ballpoint pen over there. Okay, before starting to the solution, I really request to you kindly subscribe my channel so that you can find the latest paper solutions of all Cambridge, IGCSE, Edexcel, Pearson Edexcel, and GCSE for international A levels and GCSE for AQA levels. Also, you will find the solution of these latest papers over there with the passage of time. Okay, let's start our solution for the question number 1 here, where he is saying this question is about the elements, compounds, and mixtures. Elements, the purest form of matter. Compound, when elements chemically combine with each other. Mixture, when they are physically mixed with each other. The box gives the names of some substances: calcium, chlorine, helium, neon, petrol, silicon, and water. Give the name of a compound. Compound is basically, I will say, water, because it is made up of hydrogen and oxygen. They are chemically combined with each other. So we will say here H2O as water over there. Let's move to the next part. Name the mixture. Mixture is here petrol, because petrol is having the mixture of organic compounds, hydrocarbons over there. So it is mixture. After that, he is saying give the name of diatomic molecule. Diatomic calcium. No. Diatomic molecule. Helium is monoatomic. Neon is monoatomic. Silicon is also monoatomic. Only I will go with fluorine, which exists in nature as F2. So we will say it is fluorine molecule. Fluorine molecule over there. And at the end, give the name of a metal element. Only calcium is a metal because it belongs from the calcium is a metal which is alkaline earth metals. Alkaline earth metal belonging from second group over there. All right. Here he is saying name the technique used to separate crude oil into fractions. So that is fractional distillation, in which I will say here that the components are separated by heating up to their boiling points, and vapors are passed through the condensation process, and their fractions are separated out. That is fractional distillation over there. After that, give one use of kerosene fraction over there. So kerosene fraction is used for jet fuel oil. It is used for jet fuel oil over there. It is used, and we can say aviation fuel. We also named it as aviation fuel over there. That is kerosene oil over there. Okay, let's move to the next question over there, where he is saying magnesium reacts with dilute hydrochloric acid to form magnesium chloride and hydrogen. We know that when metal plus hydrochloric acid as an acid react with each other, they produce salt plus hydrogen gas, like 2HCl. I have given the balanced chemical reaction. So he is saying it is the reaction is exothermic and magnesium is in excess. What is meant by exothermic? Exothermic means we can say when reaction is happening, amount of energy is given out to its surrounding. The reaction in which energy is released into surroundings when reactants are converted into products is called exothermic over there. And in case of exothermic, remember that enthalpy change is always negative over there. Complete the chemical equation. Okay, we have already done this. MgCl2 plus H2 as a gas to be taken into account. Draw the sketch to show that the volume of hydrogen gas changes with time until the reaction has finished over there. So I will say here, I will have to draw the hydrogen gas volume. It should start its graph from zero because it is a unidirectional curve over there. And then I will say it is increasing its volume and then making it levels off. Means there will be a reaction when magnesium is even though in the form of excess over there, but hydrochloric acid is having the limited amount over there. So we will say that volume of hydrogen gas as the reaction proceeds is having more steeper. And then when the reaction has processed, then we can say that there are levels of horizontally at constant volume over there. Okay, let's move to the next part over there. He is saying explain why increasing the temperature of hydrochloric acid affects the rate of reaction. Refer to the Cluyan theory. When I increase the rate of reaction, when I increase the temperature, when we increase temperature of HCl, what will happen? Hydrochloric acid. What will happen that we can say rate of reaction will increase. Rate of reaction will increase there. A reason behind that, the molecules will have high kinetic energy and molecules will have more collisions per unit time. Molecules will have more kinetic energy, and when they have more kinetic energy, then we can say more collisions per minute and more collisions between the molecules. Collisions will happen between molecules. And if more collisions are going to happen, then more successful collisions, more successful collisions are going to show us that rate of reaction has been increased and more collisions and more molecules will have their activation energy and more molecules will have more more molecules will have activation energy to show the rate of reaction at higher speed over there. So this was little bit effect on equilibria or on rate of reaction to happen over there, that effective collisions are increased and rate of reaction is increased as we increase the rate of reaction over there by increasing temperature. Draw the reaction profile diagram for the reaction showing that delta H and activation energy, label the reaction and product, reactants and products. So I will say here that the reactants are available here. Reactants are available over here. Reactants are available over here. What will happen? First, I will provide a heat to get an activation energy, and then there will be an enthalpy change to give me the products at this level. And these products are having our delta H will be the difference from reactants to products over there. That is delta H. And activation energy will be here. From here to here means that enough energy for highest level of molecules can have a reasonable energy to show that the reaction is processing over there according to given requirements. Okay, let's move to the next question there. Here he is saying the question is about group 2 elements. Group 2 elements are named as alkaline earth metals, and a sample of magnesium contains 3 isotopes. Mass of number of isotopes are given, which are making showing that they are available. Okay, mass number of isotope 24, 25, 26. For magnesium, he has taken over there, Mg over there, all right. Then he is saying mass 24, 25, 26, relative abundances are given. Okay. And it means I should go for the calculation of relative abundance over there. Then state in terms of subatomic particles what is meant by isotopes. Isotopes are the atoms of an element. Atoms of an element which have same atomic number, but different atomic mass. Atomic mass over there are called isotopes over there. Calculate the relative atomic masses of magnesium. Give your answer up to 1 decimal place over there. All right. For that one, I will have to go for 24 multiply 76.5. 24 multiply 76.5% plus, then I will have to go 25 multiply 10.5. 25 multiply 10.5. 25 multiply 10.5 plus, after that he is saying 26 multiply 13. 26 multiply 13 divided by 100. Let's go with it. 24.76.5 fraction introduced. 24 multiply bracket start 24 multiply 76.5 bracket close multiply plus bracket start 25 multiply 10.5. 25 multiply 10.5 bracket close plus bracket start 26 multiply 13. 26 multiply 13 bracket close divided by 100 equals to this equals to 24.36. So it is 24.36, and we said decimal place, 1 decimal place, so it will be 24.4 over there. Remember that you will have to look for this decimal place solution because it has 1 mark to show the answer in that format over there. Okay, let's go to the next question over there. Next part of this section over there. Here he is saying which of these compound is insoluble solid over there. So for this one, I will say here that insoluble can be sulfate, but not for the calcium sulfate to be used as asbestos over there. it can be taken, and we will have to. So remember that when we are talking about sulfates, then we can say only the insoluble sulfate is going for calcium over there. That is insoluble sulfate. Remaining calcium nitrate, magnesium sulfate, all are soluble soluble solids because they will dissolve and make a PPT of over there, not make the PPT over there. Okay. And then he is saying magnesium oxide is an ionic compound. Okay. The diagram shows the atoms of magnesium and oxygen, like 8 for oxygen and 12 for magnesium according to its atomic number, and 8 for oxygen for showing its atomic number over there. Diagram to show the structure of each ion in magnesium oxide include the charge on each ion over there. So I will say here that include the draw the diagram. Okay. Magnesium ion is going to have 2 electrons here, then 8 electrons, 2, 2, 4, 6, and 8, total 10, having the charge ion with +2, and oxygen is having the electrons 1, 2, after that 6, 1, 2, 3, 4, 5, 6, 7, and 8. And it is O with -2 charge over there. These are the structure drawn for magnesium and oxygen over there. The table lists some substances that shows which substance conduct electricity. Water, no. Solid magnesium chloride, no. Aqueous magnesium chloride, yes. Explain those observations refers to the structure and bonding and answer. So for water, I say it is having the covalent bonding, are also having hydrogen bonding. Overall neutral compound over there. So it is insulator having no free electrons, no free ions. No free electrons are ions to show electricity flow over there. Flow. After that, he said the second compound, which is solid magnesium chloride. Magnesium chloride is having no free ions in solid state, and they are not going to help the flow of electricity over there. In case of aqueous MgCl2, the free ions are hydrogen ion, hydroxyl ion, and Mg+2 ion, and Cl-1 ions are available. These ions are helpful. These ions are helpful for the flow of electricity over there. All right, let's move to the next one. What is he saying over there? He is saying a concentrated aqueous solution. All right, of magnesium chloride is electrolyzed. Chlorine is formed at the positive electrode named as anode. Okay. Give half equation of the reaction at positive electrode. Then I will say here maybe two chloride ions having negative charge are attracted towards positive electrode and going there, making Cl2 as a molecule and also releasing two electron over their surface over there. Okay. After that, give a reason why reaction is classified as oxidation, because we know that chloride ion is losing electrons, and to make chlorine with zero oxidation state to make a chlorine molecule. So loss of electron is called oxidation over there. After that, he is saying in the next question, number 4, he is saying that this question is about the reaction of ethanol and ethanoic acid. Ethanol reacts with potassium dichromate to form ethanoic acid. Name the other reagent needed to in this reaction. So remember that ethanol reacts with potassium dichromate to show the oxidation, because potassium dichromate is the oxidizing agent. And he is asking what should be the reactant over there more as a catalyst like that. So I will say here it can be H2SO4, or it can be phosphoric acid, which we say H3PO4. These two are the reactants. These two are the catalysts which are required from this reaction over there. And he is saying state the color change occurs when ethanol reacts with potassium dichromate, then oxidation is going to happen. Remember that they are changing their color from orange to, I think so it was green. Orange to green over there. Ethanoic acid reacts with solid sodium carbonate. Complete the calcium carbon. Okay. So it will be CH3COONA, the salt. Then there will be carbon dioxide and there will be water. Carbon dioxide, water, and salt. CH3COO with Na. Na2 is done. It is balanced. So I'm using 2 is already given over there. Carbon dioxide is staying as it is, and it is also staying as it is, but it is doubled. So I will take here doubled molecule formation over there. So this is the salts formation for both of these reactions. State 2 observations which you will observe in this reaction. We will say that because of this carbon dioxide, it will be showing bubbles to be formed. Bubbles to be formed. And we can also say that when bubbles are formed, then fizzing has happened. Fizzing is happened, and effervescence is being taken. And I can also say here that there will be a loss of vinegar smell. Loss of vinegar smell over there, which is present because of this acetic acid over there. These were the 2 observations which I have noted over here. Now he is saying a student prepares the ester ethyl ethanoate by reacting ethanol with ethanoic acid. This method mix equal amounts of ethanol and ethanoic acid in boiling tube. Okay. Add a few drops of concentrated sulfuric acid and place the boiling tube in hot water bath for several minutes. State the role of sulfuric acid in this reaction. That will be just like a catalyst. Catalyst to speed up the reaction. To speed up the reaction over there. Because in products, it is not going to be taken as any role over there. State why the student heats up the mixture in water bath instead of directly Bunsen burner flame. Then I will say ethanol is inflammable, or it can ignite. It can ignite. Like when directly I will show the flame over there, it can ignite and it can start burning by itself while showing the combustion phenomenon over there. State how the student would know that ethyl ethanoate has formed. Then I will say here that there will be a fruity smell, there will be a sweet smell. Fruity or sweet smell will be coming out, then it means this is the symbol that ethyl ethanoate has been formed. Draw the displayed formula for ethyl ethanoate. So CH3, then C double bond O with O. Then I will say here C with HH. This is ethanol side over there. Then it is CHHH. So this is the displayed formula for ethyl ethanoate over there. Okay, let's move to the next question. This is question number 5. A student does a titration to find the concentration of the solution of sulfuric acid. Fill the burette up with sulfuric acid and record the reading, H2SO4, and record the reading. Transfer 25 cm cube of potassium hydroxide solution to a conical flask over there. Potassium hydroxide, KOH. Add a few drops of methyl orange to the conical flask. Place the conical flask to a white tile. Swirl the flask continuously while adding sulfuric acid from the burette. Keep the adding sulfuric acid until end point has been reached. Record the rough reading at the end point over there. So end point, when you have stopped the sulfuric acid from the burette, you will have to record the reading over there. Okay, now he is saying name the most suitable piece for 25 cm cube of potassium hydroxide. That will be pipette. That is the most suitable to get the exact volume of 25 cm cube of the solution over there. State why the student places the conical flask on a white tile so that he can observe, so that he can observe the color change very clearly over there. Okay, let's move to the next one. Here he is saying the diagram shows the final burette reading. Okay, it is the final burette reading where it is 33. Okay, 32.2. So it is 32.25. So the initial reading is given by the table. The final burette reading is 32.25. 32.25. And after that, he is saying the initial reading is 4.5. Then I will have to subtract both of them. Then I will say 32, 4, 28.10 cm cube will be the reading as volume of sulfuric acid. Then he is saying the student repeats the titration more accurately 4 times. 27, 27, 27. So he will say 27 is 0.40. Concordant result. Okay. 27.65. No, it's not exactly going towards that. Fine. So I'm leaving it. And then I'm saying I'm going with this one, 27.30 and 27.35. Because this is very far away. It is showing 0.30, 0.35, approximately equal to 0.40. So I can take 27, 27, 27. But in this case, if I go for round off, then I will get 28 cm cube. So I'm taking as a wrong value over there where he said I will have to place the tick signs where 0.2 cm cube is the concordant result for each other over there. 0.20 accuracy should be taken over there. Use the concordant to calculate the mean volume of the result over there. Then I will say here that I will go with 27.4, 27.3, 27.35. So it is the middle value. And I'm getting it 27.35 cm cube as my mean value of the solution. No need to use the mean formula over there properly to calculate that. You can ignore that formula over there. Okay, a student also does titration. The student 25 cm cube of potassium hydroxide KOH with a concentration of 0.4 0.5 mole per dm cube. The mean volume of sulfuric acid is 26.5. The equation is KOH plus H2SO4 K2SO4 plus water. Calculate the concentration of the sulfuric acid is equal there. So remember that when we are going to calculate the concentration, then first we will have to go for calculation of I will say here number of moles. Then number of moles have the formula N is equal to C multiply V, concentration multiply volume. Concentration is 0.5 multiply. I will also have to divide this 25 to convert it into dm cube, because concentration is given in dm cube. For volume, I will also have to convert it into dm cube. So volume will be 0.025 dm cube over there, and concentration C will equal to 0.5. So I will say here 0.5 multiply 0.025. Let's go for it. That is equal to zero point 0.5 multiply 0.025 is equal to 1 by 80, which is equal to 0.0125. 0.0125 moles are available over there. If I look towards sulfuric acid from the balanced chemical equation there, then I will say here that it is half as compared to the number of moles of QH. It is half. So I will have to divide it by 2 over there. And after dividing it by 2, 125. So it is 0.00625. So it will equal to 0.00625 there. That will be the number of moles now. And now I will have to go for concentration of sulfuric acid. Then I will say here go for calculation of their concentration. Concentration will be number of moles by volume over there. So it is 26.50, also divide by 1000. 0.0265, and I will say here that number of concentration will equal to number of moles over volume. I have just used by twisting this formula over there, and now I am saying here number of moles which I have calculated 0.00625 0.00625 divided by 0.0265. I think so you have got what I did till here. And from here, if I get the solution, then I will say here he is saying to place the values in this format, like 0.00625 divided by 0.0265 equals to 25 by 106, which is equal to 0.23 round off 6, 0.236. So I will say here it is 0.236. I have rounded it off 5826 over there. Okay. He says that the student repeats his experiment and repeats the titration without methyl orange indicator. They add exactly 26.50 sulfuric acid to the potassium hydroxide solution. Describe how student could obtain pure dry potassium sulfate crystals from the reaction mixture. So I will say here the complete crystallization process should be done. And I will say here that he should use potassium sulfate crystals K2SO4 to heat up and evaporate maximum water and then allow the salt to settle down in proper crystals form over there. And if you will not allow it to cool down slowly at normal rate, then crystals will not be going to exactly form in proper structures over there. Okay. Let's move to the last question of this paper now. He is saying that hydrogen reacts with iodine vapors to form hydrogen iodide. All right. Equation hydrogen iodine 2Hi plus 226. It is endothermic little bit. Give the test of hydrogen. Hydrogen test is just like a lighted burning flame with splint pokes over there. Like it gives a flame. It gives a lighted flame with splint pops. Splint pops over there. State the symbol. What does it represents? That the reaction is a reversible reaction. Means the reactants can produce products and products can produce reactants over there. After that, he is saying in a sealed container at equilibrium, the reaction conditions are 500 degrees centigrade and 2 atm. In a sealed container, the temperature of the reaction mixture is increased to 600 degrees centigrade, but the pressure is kept as 2 atm. All right. Explain the effect, if any, on the yield of hydrogen iodide at equilibrium. I will say that yield will increase. Yield will increase because it is endothermic reaction. Even though you have kept your pressure as constant, as reaction shifts towards right side, as a reaction shifts towards a right side over there, and we can say it is endothermic over there, and it will be forward endothermic reaction. I think so. The concept behind this explanation is much more clarified to you by this explanation. The pressure of the reaction mixture is decreased to 1 atm and the temperature is kept 500 degrees centigrade. Now he is asking if the temperature pressure is decreased, then what will happen? Because if you observe the chemical equation here, it is having 1 mole here, 1 mole here, and 2 mole here. Total 2 moles on this side, 2 moles on this side. And the number of moles on both sides of the equation is equal. So there will be no effect of pressure change at equilibrium. If the different number of moles on both sides as a reactant and product, then I must say that there will be change and there will be a problem for going for that to check the number of atm pressure. And excess of hydrogen reacts with 50.8 gram of iodine. Okay. At equilibrium, the yield of hydrogen iodide is 80%. So I will say it is 80%, that is hydrogen iodide. All right. Calculate the volume in cm cube of hydrogen iodide produced at room temperature and pressure and give your answer in standard form. Room temperature 24,000 cm cube. So first of all, I will have to go for total number of moles for iodine, number of moles for iodine over there. I will say mass in gram, that is 50.8 divided by, if we go for the molar mass over there, then I will say it is 254 molar mass of iodine over there. And then I will say 50.8 divided by 254. 50.8 divided by 254 is equal to 1 by 5, which is equal to 0.2, like that. 1 by 5, which is equal to 0.2 moles. After that, after calculating the moles of iodine, I can also observe that number of moles of iodine when I will have to go for hydrogen iodide, number of moles of hydrogen iodide, because I know that is given as 80% as its percentage. Then I will say here that I should say 0.2 into 0 plus 2 multiply 80 divided by 100. So it is 8 to the 16, and 80 multiplied by 2 is 160. 160 divided by 100 giving us 16. And we know that hydrogen iodide has double number of moles over there from the balanced chemical equation. So I will say here that it should go for doubling also. So it should be 0.32. Remember that it was 160 divided by 100, 0.16. Then I said number of moles should be doubled according to balanced chemical equation. Then I took 0.32 as moles over there. So volume of hydrogen iodide will be given as volume of hydrogen iodide 0.32 multiply 24,000 cm cube, and you will get your value 0.32 multiply 24, 1, 2, 3 equals to 7680 cm cube. So it was the solution of your complete paper, which you have done for today. Kindly subscribe my channel so that you can get the solution of all the sciences, physics, chemistry, math, and biology, the latest paper solutions over there. Thank you so much for today, and best of luck for your exams over there. Thank you so much.